Hi ladies, it's Mr. O'Sullivan. Today we're going to be looking at lesson 6-4, Exponent Basics, 0 negative exponents. Today's learning target is, I can apply the rules of exponents by simplifying expressions containing 0 and negative exponents. So up top we have some of our exponent rules we've been looking at. We've looked at this rule right here. So basically when we multiply exponents with the same base, we add our exponents. When we divide, we just subtract our exponents. And when we raise a power to a power, we actually just multiply our exponents. So let's do a quick little exploration. Fill in the table values below and explore some of the patterns you discover. What do you notice? So if you look, we have 5 to the 4th, then we wrote it 5 times 5 times 5 times 5, and we get 625. So if I have 5 to the 3rd, how many 5s will I write? I'm going to write 3 5s. So I have 5 times 5 times 5, and I type that in my calculator, and what do I get? I get 125. Now, when I have 5 squared, and I want to write that in expanded form, I write 5 times 5, which will give me 25. And then when I have 5 to the 1st, I just have 1 5. So I get 5. However, when I have 5 to the 0, type that in your calculator. What do you get? I get 1. There is no expanded form. There's nothing there. Now, whenever you have a negative exponent, what I want you to do is basically just make it a fraction. So this 5 to the negative 1, I've got 1 5. It's going to become a 1 over 5. And that's it. Now, I have 5 to the negative 2, which means I have 2 5s, both in my denominator. 5 times 5 is 25, so I get 1 over 25. And then I have 5 to the negative 3, which is 1 over 5 times 5 times 5, which is 1 over 125. So one of the things I'm going to ask you on your edPuzzle is, what do you notice? So what do you notice? I want you to tell me 2 things that you notice about your table of values that we just came up with, going all the way from 5 to the 4th to 5 to the negative 3. Look at your final answers. What do you notice? So I notice that as I decrease my exponents, so the more negative I get more bigger, like I get fractions with bigger denominators. I also notice that the higher my exponent, the larger my number. So exponent rules to follow. Add these to our already large list. So we've already learned, I believe, 3 or 4 rules. Now we're going to learn 2 more today. The 0 exponent rule. Whenever you raise something to the 0 power, you're not going to get 0. You're going to get 1. So I just get 1. Whenever I raise something to the 0 power, I just get 1. Now, here's my negative exponent rule. My negative exponent rule says that you just put your negative exponent wherever it is in the opposite spot. So if it's in the numerator, you put it in the denominator. If it's in the denominator, you put it in the numerator. So I basically just flip it. So I get 1 over x to the a. So negative exponents mean that your base is in the wrong place. Your expression is not simplified until everything is in the right place. Just the warning. You got to make sure everything is in the right place. So let's go on to this example. If you look, I have rewrite each of the following using only positive exponents. Do not worry about simplifying. So we only care about our exponents. We don't care about our coefficients. So we care about our x to the negative 5, our x to the negative 3, our y squared, and our y squared. If you look, these are my negative exponents, so I'm only moving my x's. So I keep this the same, so I have my 3 over 4, but now I'm going to put my x to the negative 5 downstairs and my x to the negative 3 upstairs. And I'm going to keep my y squared, y squared. That's all we're doing right now. We're just moving. Now let's look at our second example. If I look at my second example, my 6 and my 2 stay in the same spot because those are my coefficients. I look at my x's. I have an x to the 3rd and an x to the 4th. Those are in good spots as well, so I'm going to keep them where they are. I have a y to the negative 2. I don't like that, so I'm actually going to put that downstairs. And I also have another y2 downstairs that I'm going to keep there. I like where my z to the 4th is. I don't like where my a is, so I'm going to bring that a to the negative 5 downstairs. And that'd be our final answer. Now let's go on to the next one. If you look, everything's negative, so we're basically just going to rewrite our fraction. If you look, my x to the negative 2 will go downstairs. My x to the negative 3 will go upstairs. My y to the negative 2 will go downstairs. My y to the negative 3 will go upstairs. So I get x third y third over x squared y squared. Okay. Now let's go over how we can actually simplify these expressions. Practice. Rewrite each of the following as a simplified expression without using negative or zero exponents. Remember, divide coefficients when needed. So if you look at our first example, we have 5 to the negative third. The first thing I'm going to do is I'm going to rewrite this as over 1. Thing is, I don't like my negative 3, so I'm actually going to be moving my whole 5 to the third, negative 3 downstairs. So I'm going to get 1 over 5 to the third. Can you tell me what 5 to the third is equal to? Very good. It's 125. So I get 1 over 125 as my final answer. B, 6 to the 0. Remember, anything to the 0 power is equal to what? It's equal to 1. So I can just say 6 to the 0 is equal to 1. 2 to the negative 5th. That's the exact same as part A, where I had 5 to the negative third, but instead of raising it to the negative 3, I'm raising it to the negative 5. So I'm going to be putting this as 1 over 2 to the 5th. Can you tell me what 2 to the 5th is equal to? Good, I get 32. So I get 1 over 32. 4 x to the 0. If you look, it's not 4 to the 0, x to the 0, it's 4 times x to the 0. So we know x to the 0 is going to be equal to 1. So I'm just going to do 4 times 1. What's 4 times 1? 4. Now, my 4x is being raised to the 0. Anything raised to the 0 power is just 1. F. I don't like where my x to the negative 2 is. This is really over 1, so I'm going to make this y to the 4th over x squared as my final answer. First thing we're going to do is divide our coefficients. So I have 15x to the negative 2, y to the 6th over 3y to the negative 3, x to the negative 5. So I really have 15 divided by 3, which is 5. So I have 5 x to the negative 2, y to the 6th over y to the negative 3, x to the negative 5. Remember, we're going to move everything. So I keep my 5 and 1 where they are. Don't like where my x to the negative 2 is, so I'm going to bring it downstairs. What I'm going to do is I'm going to cross out things as I rewrite them. I don't like where my y to the negative 3 is, so I'm going to rewrite it up in my numerator. I like where my y to the 6th is, and I don't like where my x to the negative 5 is. Now I combine. We know y to the 3rd and y to the 6th will give us y to the 9th, so I have 5y to the 9th over 1x squared. So I have 5y to the 9, x to the 5th over 1x squared. If you look, I can actually simplify my x to the 5th and my x squared. X to the 5th over x squared. What's my highest exponent? My 5. 5 minus 2 is 3. So my final answer is going to be 5y to the 9th, x to the 3rd, all over 1. Or you can just leave it as 5y to the 9th, x to the 3rd as your final answer. And that's it for today. There is no delta math, so just make sure you have this edPuzzle done. And I'll see you on Zoom tomorrow. If you have any questions, email myself or Miss Townsend. Have a great day, ladies.